We're going to use trigonometry here to solve right triangles. And so when you're solving a right triangle, it means to solve for all of the triangles missing information. So in this picture, in this problem, which this is probably going to be the only one I put in this video, in this problem we are missing the side MN, and we are missing angle N and angle M. And so we're going to be finding those three parts. And as we find those parts, you'll notice this one is special because we don't know our reference angles. We don't have one to use with sine and cosine and tangent. So the ones where you have a reference angle, you're just going to work it just like we did on the previous video. You're going to find the missing sides and really just add the triangle sum. They add to 180. So you find your missing angle by subtracting from 180. So that part is real easy for you to do. This one, though, is different. So I wanted to do this type of question. Now, the first thing I like to do is I like to make a list of what I'm missing, which is what I've got right here. I like to make sure I know what to round to. We're rounding to the nearest tenth for all of these parts, even the side length. Make sure that you do a tens place, even if the answer is a whole number. Add a 0.0. On this problem, though, I've already done it, so I already know the answers. Mn is found with Pythagorean theorem. So 15 and 7 are the legs. So we're going to do 15 squared plus 7 squared equals to c squared, and then solve for c. As we solve for c this way, you will get, let's see, let's go to the calculator. 15 squared and 7 squared. 15 squared and 7 squared, because they were my legs, enter, and then square root that. Now, if they didn't tell me where to round, I would of course want a radical form answer. But this one said nearest tenth, so I can round on this one and go ahead and get a decimal. So nearest tenth place would be 16.6. I just wanted to make sure I rounded right on my paper. 16.6. So Mn, not really C, 16.6. And they didn't have units here, so we don't have like feet or inches or anything like that. The next thing to do is to find the missing angles. And you don't have to find M first, you can find N first. It's whichever one you like better. As far as you're going to label your triangle based on this angle. So whichever angle feels more right for you with labeling. For me, M is up here. I don't know, I just didn't want to use M. I felt like N was a better one for me to use for labeling. That's just personal preference. So then label your triangle. Opposite from N is the 7. That's the opposite side. Label the hypotenuse. I'm not going to use the hypotenuse because it was this crazy decimal answer, and I've already rounded that. If I use that, my rounding is going to be off. The other side would be the adjacent side. So to find the angle, we need to have two side measurements that we actually know. So we know this one's 7 and we know this one's 15. So we're going to use those angle measures for our setup. So remind yourself of the function, like the rule here. Some old horse caught another horse. Sadly, I still have to say this saying. Taking oats away. There we go. All right. So I wrote down the rule here, and I know that I'm using O and A, which means that I'm going to use the tangent function. So the tangent, and the angle goes here. Well, I don't know the angle, so going to put a capital N there because it's angle N. Why not? So the tangent of the angle equals to the opposite over the adjacent. So that would be 7 over 15. So when you want to find the angles, you use the trig function differently. You don't use the normal trig function that we used in the previous video. You're going to use the inverse tangent. It's kind of weird. It's super easy Once people learn how to use this, though, they try to use the inverse tangent on like every problem, and that is not what you want to do. You only want to use the inverse function if you are finding an angle. So it will look like this, the inverse tangent with a power of -1. And then it will open a parentheses for you in your calculator. And then inside of the parentheses, if this pen thing would go away, inside of the parentheses, you're going to put the ratio. And then that will equal the value of the angle, the n. So it's kind of like getting the angle out of this expression by doing the inverse of the ratio there. So inverse tangent of 7/15 will give you the angle. So I'm going to show you how you do that in the calculator. So instead of using tangent like normal, you want the blue writing above it. So you want to push second and tangent and see how you get the inverse. And then you write the ratio that we had, which was 7 divided by 15. And then you don't have to close parentheses, but I just do have it. There we go. And they had said nearest tens place, so that would be 25.0. We do need to write the 0.0. 25.0 degrees, because it is an angle, so that is like a unit of measure for that. So 25.0 is this angle. Now you can use that angle and the fact that this one is 90 and use a triangle sum to find angle M, or whichever angle you didn't find at the beginning. So you're just going to think of 180 minus 90, which leaves 90, minus the 25.0, which is going to give you your other angle of 65.0. So this one is 65.0 degrees. And then you have all the missing parts, and you have solved the triangle. So solving a triangle just means finding its missing parts, and in this one we were able to know how to find an angle using side measurements that we have, which that's how you're going to do some of your Sphero project. I just want to kind of demonstrate, if you had your Sphero and it sort of was like this for your track, and you wanted to make it turn here like so, what you would have to do is you would have to extend the path that it was on, and you would use the path that you are hoping to have, and you create a right triangle. And in this right triangle, the path extension where the Sphero would go, you need the angle of turn right here with the extension and the new path. You will need to use your gridded paper to find these side measurements of this triangle. I'm just going to act like this is 4 and this is 3 or something like that, okay? Then you would have to calculate this angle measure. So this is the opposite from it, this is the adjacent to it, and this is the hypotenuse. So we're using the opposite and the adjacent to find the angle. I'm going to call it x. And so that's going to be tangent. So we would say tangent of x equals the opposite over the adjacent. And then, of course, we're going to use the inverse tangent and type in 4/3, and that's going to give you x. So let's see what that would give us. So second tangent, 4 divided by 3. Our angle would be 53.13. They didn't tell us right around. I think we're going to go hundredths place if the device will let us program with that. It's going to be more accurate. 53.13 would be our angle of that turn. So we would tell the Sphero, go this far, turn left, 53.13 degrees, go for this long. Then we would calculate that next turn, and so on for our path. So Anyhow, I hope that gives you an idea of how you can start calculating some angles for the Sphero project.